Today's lesson is about polynomial functions and composition. The essential question for this lesson is, how do you recognize, evaluate, and find the composition of polynomial functions? So the general form of a polynomial function would look something like this. This would be f of x is equal to a sub n, x to the n, plus a sub n minus 1, x to the n minus 1, all the way down to a sub 1, x, plus a sub 0. This would be a polynomial function of degree n, where the numbers, all the a's are real numbers, and where n is a whole number. So let's look at an example. So let f of x equal 4x to the third minus x to the second plus 5. And we want to find what is the value of f of 3. Well, in order to find it, you simply plug in 3 for x in that particular function. So if we plug in 3 for x and solve our function, we come out with f of 3 is equal to 104. So basically, what is this telling us? This is telling us that the ordered pair 3, 104 belongs to the function. Or if we were to graph this function on the xy coordinate plane, the point x equals 3, y equals 104 would be on the graph. So now let's talk about adding and subtracting functions. Let's start by looking at an example. So let's say we have two functions. F of x is equal to x squared minus 3x plus 7, and another function, g of x, which is equal to minus 3x squared minus 7x plus 7. And let's say we want to add these two functions. Now we can write this in two different ways. We can either say f of x plus g of x, or we could use a shorthand method of saying f plus g of x. So we write the two functions down, and at this point we basically do the same thing we did when we were adding and subtracting polynomials. We're going to look for like terms and combine the like term. So I notice I have an x squared, and here's another x squared term. It's minus 3x squared. I have an x term, and here's another x term. And then lastly, I have a constant term here, the 7, and another constant term here. And if we add those like terms together, our result is going to look like this. Minus 2x squared minus 10x plus 14. So this is how we go about adding functions. Now, if we are subtracting functions, it's very similar. Say we had f of x minus g of x. Again, we could write that in shorthand and say f minus g of x. And if we plug in the two functions and subtract, so if we first would get rid of the parentheses, be careful of the minus sign. Basically, everything on the right side here, the signs change because of the minus out in front. And then combine like terms, our result would simply be 4x squared plus 4x. All right, so now let's look at evaluating this difference function, f minus g of x. Let's say we want to find the value of f minus g of 3. So we simply plug in 3 for x in the f minus g of x function. And that'll give us 4 times 3 to the second power plus 4 times 3. And if I crank those numbers out, I come out with an answer of 48. All right? Now, I'd like you to try something here. Why don't you take the sum function? So, I'd like you to evaluate f plus g of 2. So take the f plus g function and evaluate it at x equals 2 and post the answer in the drop box. Okay, so now let's talk about composition of functions, or the term that I prefer is that called composite functions. Now, composite functions are represented or written in this manner. Okay, a lot of the books use this little 0 here, and it looks to me like you're spelling out fog. I don't particularly like it. My preference for composite functions is to write it the way it is on the right, f of g of x. Because to me it just is a lot clearer, and when I give you an example, I think you're going to see what I mean by that. So for our example, let's say that f of x is simply equal to x squared and g of x is equal to x plus 3. And I want you to find f of g of x. Well, how do we go about it? Well, much like order of operations, when you have nested parentheses or parentheses within parentheses, you start on the inside and work your way out. So as I said, we just start on the inside, and if we look carefully at this, and we see g of x, well, what is g of x equal to? Well, g of x is equal to x plus 3. So I simply take x plus 3, and I plug that in place of g of x. Well, now what do I do? Well, what does the f function say? The f function says whatever's in the parentheses, we're going to square it, because f of x is equal to x squared. So what's in the parentheses? X, we square it. Well, now we've got f of x plus 3. So I'm going to take what's in the parentheses, and I'm going to square it. So our result is simply x plus 3 squared. All right, well, to help you further understand this, let's determine what g of f of x is. Well, g of f of x, remember what I said, we start on the inside. Well, what is f of x? F of x in this case is x squared. All right, so I take x squared and substitute it for f of x, and now we have g of x squared. Well, what is g of x squared? Well, the g function says take what's in the parentheses and add 3 to it. So let's see what our result's going to be. So if I take what's in the parentheses, which is x squared, and I perform the g function, which is simply to add 3 to it, my result is g of f of x is equal to x squared plus 3. So now I'd like you to take and try something here, and that is to evaluate the f of g function at x equals 2. So I'd like you to figure out what f of g of 2 is equal to. So f of g of 2, and put that answer into the drop box, and come to class next time, and we'll answer any questions and do more of these sample problems.